So we're okay. We're on the fifth chapter of this human-computer interaction. So our topic for this chapter is user interface layer. So I think we already know what is a UI, the user interface. No? So it's part of the system in which the user interact. So it also defines the way in which the user will interact with the application or the system, and the nature of the inputs and outputs that the application or the system accepts and produces. So in this chapter, these are the our learning objectives. So we're going to learn on or to understand the UI layer and its execution framework, and then the input and output at the low level, then processing the input and generating the output, and then last is the output. All right, so let's proceed with understanding the user interface layer and its execution framework. So interactive applications are implemented and executed using the user interface software layers. So the UI layer refers to a set of software that operated above the core operating system. So any applications that we're going to open the or use or are implemented in the UI software layers. So kaning UI software layers are kanang naan siya yung mga set of software that operates. So it then enclosed with kanin siya mga software ano siya it enclose some system functions. So like first we have here the fluid input and output fluid wala nila ba fluid input and output, then the facilitation of development of the input and output functionalities in form of an application programming interface or the API or a toolkit. So later in this chapter we're going to discuss more detail on the toolkit. Then, but when say API, to give you some background muna, the API is, muna siya ang software that allows two applications to talk to each other. So, mag-allow niya siya, mag-communicate niya siya, i-allow niya to, para mag-communicate ang duwa ka applications. So, each time you use an application like Facebook, mag-send ka instant message or messages or check the weather on your phone. So you're using API or the application programming interface. Then we have the runtime management of graphical applications and the UI elements, often manifested as windows or graphical user interface or the GUI elements in the form of separate application, often called the window manager. So we say window manager mo sila ang ilang job is to handle how all of the windows created by various applications that share the same screen and who gets user input at any given time. So ilang work is for example nag-open ka sa imong computer or nag-open ka multiple windows. So iyang trabaho is to control, no, to control those applications like i-control niya ang sa imong i-balance niya ang imong performance, mga energy usage and others. So mo na siya ang window manager. And then next is okay. Since most interfaces are graphical, so UI layer uses a or three-dimensional graphical system based on which GUI elements are implemented. So in the UI layer, it is largely composed of kani sila. Ang sa UI layer composed ni siya one is the API. An API for creating and managing the user interface elements. So, mga to sila. So, itong API, Application Programming Interface. So, mga sila ang, for example, mga windows, mga buttons, and menus, and etc. And window manager, composed ni sa ang UI, it also composed of a window manager. So, once upon window manager, it allow users to operate and manage the applications through its own user interface. Matamingan ganiya mao to sila ang mag-work or mag-manage sa imong mga applications sa imong computer, sa imong screen. Mao na ang Windows Manager. So, basically, UI is composed of the API and the window manager. So this is how the UI software layer execute or the framework. So in this figure, it illustrates as part of the system UI software layer. So the user interacts with the window GUI applications. So nag-interact siya sa window GUI na base applications using various input and output devices. So at the same time, is dili lang isa ang application niyang gigamit but multiple applications. So I mean nag-manage po siya og mga multiple application Windows task. So using the Windows Manager system. So iba ang Manager system is allow niya ang it control all the applications sa imong system, sa imong interface. So here the window manager is regarded as both application and then your API. So unsa itong UI, it composed of your API and the window manager or the application. So here ang GUI niya is ang GUI elements is katong mga widgets, mga windows, menus, buttons. So makita niya dani sa UI user interface layer. So Windows API naman kung dagan siya gayon na open, so as you can see dagan yung gi-open. So mo siya ang mga window managing like katong resizing, dragging, copy and paste, and etc. And it's it's above on the operate and execute sa above sa or above sa operating system. So basically mao na siya ang concept sa interface software layer for a multi window multitasking UI. So that's for understanding how the UI layer and execution framework dito. Ang UI is UI layer composed of an API, meaning application programming interface, and then we have the GUI. I mean the Windows Manager. Windows Manager. So Windows Manager mo na sila ang mag-control sa mga applications. So ilang job is to handle how all our Windows ma-control sa ka-screen and who gets the user input at any given time. For example, katong mag-open kag Windows, dagan kayo muna open na Windows. So the moment you click or i-click nimo ang kuan katong isa ka window, so mao siya ang mag-control makuan dito sa Windows Manager. So mao na siya ang understanding the UI layer and its execution framework. So let's proceed with the input and output at the low level. So at the lowest level, inputs and outputs are handled by the interrupt mechanism of the system software. So an interrupt is unsa ning interrupt? It is a signal to the processor indicating that an event has occurred and must be handled. So in the lower level ang there is an interrupt mechanism, meaning ang kaning interrupt it is a signal, mo signal siya sa processor na naay event na mahitabo or naay mo arrive nga event, and this must be handled. So an interrupt signal is interpreted so that the address of its handler procedure can be looked up and executed while suspending the ongoing process for a moment. So after the handler procedure is finished, the process resumes again. So mao na siya ang i-interpret din niya ang uh, address of the handler para ma-execute siya sa processor, then ipasa din yan dito sa handler. So in practice, so this means that the processor is always listening to the incoming events, ready to serve them as needed. So the interrupt mechanism is often contrasted to pooling or known as busy waiting. So ang processor is always listening kung nabay mo incoming na mga events. So kung naay moabot, so entertain niya, i-serve din niya, and then katong while napa siya gina-entertain, i-suspend sa to niya, i-entertain na siya yung incoming. Once kuan na tong entertain niya to yung incoming, mo resume din siya katong sa last niya na kuan gi-entertain. So mo na siya ang sa processor. So mao na siya ang the interrupt mechanism is often contrasted as to pooling na siya sa pool, so, or busy waiting mo na siya. So in pooling, the processor initiates input and output. So in order to carry output tasks, the processor enter a loops continually checking the input-output device's status to see whether it is ready and incrementally accomplishes the IOS task. So that's for the low level. Low level input and output low level. So katong low level is mong signal siya o na siya interrupt na signal na in which ipasa niya sa processor. So here now is at the higher level. So the input-output operation is often described in terms of events and event handlers, which is in fact an abstraction of the lower level interrupt mechanism. So kani sa higher level na pod is naanda ni ang events and event handlers. So this is generally called the event-driven architecture, in which programs are developed in terms of events and their corresponding handlers. So in this figure, it is a complex. It's a complex mechanism constructed as an event handler table. So as you can see, the moment mag-send ang device, input or output device mag-send og interrupt signal sa low level, di ba ang interrupt signal. So the moment mag-send siya, kuan din ipasa niya sa processor, mag-signal siya sa processor or na incoming na event. So the processor will entertain will listen to the incoming events, then reserve them, ready to serve them as needed. Then ipasa din diya dito sa memory. So I mean sa handler. So then the memory reads it, then it stores on the interrupt handler address table. So nakastore na ang mga index address and its memory content. Then after that, then jump to address, then i-compute ang index into interrupt under jump to address kung sa na address, then go to the handler table. Last is the handler table or the abstraction. So mao na siya ang mahitabo sa input and output na kuan, low level and high level. So that figure shows a rather complicated interrupt mechanism abstracted into the form of simple event handler table. So ginap from the interrupt signal, pasa niya sa processor, then to the event handler table. So that's uh, uh, the the idea of the input and output sa low level and high level. For processing the input and generating the output, we have here some events, the UI objects, and the event handlers. So the most basic UI object in today's visually oriented UI system would be the window or layer. So window is a rectangular portion of the screen associated with a given application that is used as a space and channel for interacting with the application. So karang whenever you're mag-open ka like my computer, isa na ka window. So another kung open up ka excuse me application, mao na isa na pod siya. It's another type of window. So other UI objects include buttons, menus, icons, forms, dialog boxes, text boxes, and so forth. So these are often referred to as GUI objects or widgets. So GUI-based interactive applications would have a top window that includes all other UI objects or widgets that are logically and or spatially subordinate to it. So as you can see here in this figure, this is an example of a window there is a root background window activated by default upon system start and also serving as the top window for the window manager process. So as you can see, there are some icons and widgets here in your screen. So this is an example of a window. Then, so when there are multiple windows, the user carries out an action to designate the active or current window in focus to which the input events will be channeled. So kung dagan imong na-open na window, so kung once maklik nimo siya, kung katong gusto like dagan imong window, so katong current na window, once gusto nimo i-click tong naa sa iyang likod, so just kung ma-hover na nimo then click, so mo na to imong active din now window. So ang katong previous nimo may mo ito deactive din siya. So there are two major methods for focusing in your window. They are click to type and move to type. So when I click to type, the user has explicitly click on the window before making input into it. So the window over which the mouse cursor hovers becomes the focus. Mato siya kung gingon ganiya. Then move to type, an unintended change due to accidental mouse movement. So mo na siya ang due to accidental mouse movements, mao na ang move to type. Well, katong click to type, mo to imong pag-click, click nimo ang window kung unsay imong gusto na i-open. Mo na rin to ang naka-focus. So that's the two major methods for focusing. Here in the figure, this is an event being dispatched to the right. So the user will try to locate the add dialog box. Then, dali siya makuan sa iyang sa file menu or sa edit menu. So once nakita na niyang dialog box, so i-click niya, then this one is considered as event, no? An event is even event click niya dahil sa file considered as an event na. Then of course that add dialog box, kung maklik siya, it's another event. So once maklik na niya ni ang add dialog box event, so i-dispatch din niya to the right UI. So once maklik, so mo pop up din siya sa right UI. Kani siya yung right UI. And then mao na diyang mga object handler. Padulong din siya sa yung object handler, whatever na imong input niya na information here, mong padulong din siya, ma-store din siya sa imong event handler, which are your text boxes kanina example. Okay, so um, so from the top window address, dani mo naman ma-locate ang event, man siya considered mo as event from the top window. Then once you click the add, katot siya nakuan, then mo dispatch din to siya sa right UI. Then go to the event handler. Mo na siyang associated event handlers in a hierarchical manner. So that's the explanation on this figure. So whether it is the root window, application window, or GUI widgets as an interaction channel or object, it will receive input from a user through input devices such as keyboard, mouse, etc. So unsay yung mga gamit ng mga input devices, man sa considered na mga events. And then the physical input from the user or devices is converted into an event. So which is simply data containing information about the user's intent or action. So kung unsay mong gusto nimo on, mo click ba kay drag ba nimo sa imong computer or sa screen. So that's considered as an event. So it's from the input devices. So an event usually contains additional information such as its type, a timestamp, the window to which it was directed, and screen coordinates. And then these events are put into a queue by the operating system and dispatched to invoke its corresponding handler. So here, kani siya nakuan na figure, it's mo to siya ang gikuan, no, the kani siya mao ni siya ang event queuing at the top action level. So kani siya ang atong giingon niya, the event usually contains additional information so this is a event, no, contains additional information, like the type, usually its type, no, value, timestamp, and then the window, and the window to which it is directed, and screen coordinates. So these events are put into conditional events are put into operating system, naka-queue siya, then i-dispatch din niya sa kung asa na window, current focus na window. So direct then kung asa na kuan na window, then it will be kuan invoked to its corresponding handler. So man siya ang dagan ani na figure from this event, which contains this information na naka-queue siya sa operating system, then it will be dispatched to according to the current window focus, kung asa siya naka-kuan focus ang window. So then padulong niya sa corresponding handler. So that's the explanation for this. So the events do not necessarily have to be generated externally by the interaction devices. They are generated internally for special purposes, sometimes called the pseudo events. So special pseudo events are enqueued and conveyed to the respective applications or windows. So a special redraw pseudo events is sent to the application with information about which region is to be updated. So the window content might need to be redrawn not because of the window management commands, but due to the needs of the application itself, so which can generate special pseudo events for redrawing parts of its own window. So as you can see here in the figure, this would be the once dani man siya is posing a window and redrawing, i-redraw nimo kani siya na window ko kani siya kanina window. So kani siya na ko, di ba, datong giingon na um, ang pseudo event is kuan kanang it's just a ano to siya, kanang i-update lang niya, no, update, tada dani, update as a they are internally, internally special to be, kung unsa lang na region is to be updated. So dili lang siya, it's not the external na kuan but internal na sa event. So here kung gusto niya makuan ni mainani siya ma-output, yung makuan. So kung i-click na niya, so ang i-update lang sa system is kanila siya, the region kung asa na part ang iyang i-update ko. So kanina part mo na siya ang pseudo event ang titawag, withdraw handler. Okay? Area to be renewed and withdrawn. Kanina siya na ano siya ang pseudo event. That's the processing the input and generating out the events, the UI objects, and the event handler. So events mo to siya ang unsa imong ang user unsa yung i-take na action or kuan sa whatever from the input or output devices. Then UI objects katong mga widgets and mga icons, man siya, mga file, mga menu buttons, that are the UI objects. And the event handlers are where you store itong mga mo padulong ang mga information or data. So that's the how the input and process and it when generating the output. Then for that's for events, UI objects, and event handler. Then let's proceed with event driven program structure. So you can see here, this is an example of a program. So coding, the first initialization part of the program creates the necessary UI objects for the application and declares the event handler functions and procedures for the created UI objects. So as you can see, nag-initialize sa application, iya nang gi-declare ang event, ang UI objects o ang event handlers. Then the program enters a loop that automatically keeps removing an event from the application event queue and invoking the corresponding handler. So nagkuan siya, ang program nagkuan siya, naglooping din siya, system loop. Then the development environment often hides this part of the program so that the developer does not have to worry about such system level implementations. So gina-hide lang na siya, ganun siya na part. And then, so mo siya, so event-driven program structure. So mo siya ang program structure. So UI object creation and event handler setup followed by the event processing loop, either provided by the underlying programming environment system, operating system, or by explicit user programming below. So mo siya ang how this event-driven program structure looks like. So anyway, we will not detail ato. What we're trying to look here is the how the theory or how this input engine input process and it generates its output. So mo lang natong importante na mabalaan ani. So that's for processing the input and generating output. Okay, we're now down with the last part, the output. So here, interactive behavior that is purely computational will simply be carried out by executing the event handler procedure. So however, response to an event or application behavior is often manifested by explicit visual, oral, and haptic tactile output as well. So a separate step for refreshing the display based on the changed screen data is called as the last part of the event processing loop. So analogous processes would be called for sending commands to output devices of other modality as well. So an output is basically on the by explicit visual, oral, and haptic tactile output. Next, and then I see. Sometimes with multimodal output, the outputs in different modalities need to be synchronized. However, not many interactive programming frameworks or toolkits offer provisions for such a situation. So while internal computation takes relatively little time, processing and sending the new change data to the display devices can take a significant amount of time. So thus sometimes rendering and sensing parts can be separated into different independent threads and processed at different arcs to ensure real-time interactivity. So it's not only for visual oral tactile output. Sometimes it also with multimodal output. But mao pa yung ingon dani na um, not many interactive programming frameworks or toolkits offer provisions for such a situation. Okay, it's more on kuwan nga, complicated naman ko mo say multimodal, so more advanced and then complicated agad na kay kuwan na one or two uh, mo, modal output ang ikuan modalities. So that's for the output. And then I think this will be the last part of this chapter. So in this chapter we have looked at the inner workings of the general underlying software. So we have uh, discussed the UI layer or the UI execution framework. So from the UI layer, we have the concept composed of the API, the application program interface in the Windows Manager. And we have also discussed how this framework execute in the UI user interface. Then most UI frameworks operate in similar ways according to an event-driven structure. So the hardware input devices generate events that are conveyed to the software and they are processed to produce output by the event handler. So na-discuss po nato dani ang input, ang mga output at low level. So ang input, we have the interrupt, signal niya, no? I-signal katong interrupt signal, ipasa niya sa processor, then kato siya, and then the and that's mao to siya ang in low level. In the higher level we have the event handler, no. Then we have also discussed the process of the input, how the process input and generate output. So we have also discussed katong under ana the events, katong mga events, so katong events katong unsay kuan sa user button sa isa ka diha sa screen or the computer, that's called event. And then the UI objects like mga example the widgets, the icons, that's the example of UI objects, and the event handler in which asa niya store and kuan ang mga information. Then we have the event-driven program structure katong program structure sa event from katong mag-declare siya, mag-initialize siya sa application, then define niya ang UI objects and event handlers, then magkuan din siya mga loop, ano? Mo to siya ang event-driven program structure. And we have also last is the output. So katong mga modalities ng mga output. So I think these are things that we're going that so these are the topics for this chapter 5. So I hope you've learned something and thank you for your cooperation.